Well, welcome to this online revision session for AQA FP2. In this session we're going to cover the June 2010 question 1, which was on the topic of hyperbolic functions. Well, the first part of this question is an algebraic show that. So we have the left hand side, which is a function of sine and cosh, and we're going to simplify it down to the exponential function, and in order to do that we need to know the definition of sine and cosh in terms of e to the x. Having done that, then in part B you can see the same left hand side is then equal to 8, so we will have to solve an equation, and from the value that we obtain to that equation we can then find the exact value of tan x, which we should know is equal to sine x over cosh x. So, on to the first part of this question. So, do we know the definitions of sine and cosh? Well, hopefully we do. So we start off then with the left hand side, which is 9 sine x minus cosh x. So we should know that sine x is equal to e to the x minus e to the minus x over 2. And similarly cosh x is e to the x plus e to the minus x over 2. And so if we collect the e to the x's together, we got 9e to the x minus an e to the x, and they're both over 2, so that gives us 8e to the x, which of course when divided by 2 gives you 4e to the x. And similarly, if we look at the e to the minus x's, we've got minus 9 of them, minus another one in the second part here, so that's minus 10 over 2, which will give us our minus 5 e to the minus x. Only 2 marks for this part. 1 mark obviously for a method mark, for you realising what the definition of sine x is in terms of e to the x and e to the minus x, and similarly for cosh x. Get those the wrong way round, you won't get any marks at all, I'm afraid. And then 1 mark for simplifying it down to the correct answer that you require. Well, we're now going to use that result to solve this equation. You see 9 sine x minus cosh x is equal to 8, so we can replace the 9 sine x minus cosh x with the 4 e to the x minus 5 e to the minus x. And solving this type of equation should be quite familiar to you, in that if you then multiply all the way through by e to the x and take the 8 across to this side as well, we're going to get minus 8, sorry, there should be a 2x there, because e to the x times e to the x is e to the 2x, minus 8 e to the x, and then e to the x times e to the minus x, of course, is just 1, so this becomes minus 5 equals 0. So here you can see we have a quadratic in terms of e to the x, and so all we got to do is think about, well, this quadratic, how can we factorize it? Well, e to the x times e to the x is e to the 2x. To get 4 lots of e to the 2x, it could either be 1 and 4 or 2 and 2. The 5, well, we know it's going to be minus 1 and 5, or 5 and minus 1. Since we got minus 8 here, lots of e to the x, it's likely that this will be -5 and +1. And so putting in, we can either try the 1 and the 4, but that would give you -20. 4 and the 1, that wouldn't give you enough of the 8e to the x's. So I think this must be twice e to the x and twice e to the x. Alternatively, if you don't like trying to factorize it from here, you could substitute e to the x into this expression, replace it with big X, and factorize the quadratic 4x squared minus 8x minus 5 equals 0, and obtain your values for e to the x that way. And so you can see from this we've got two possible values of e to the x. To make this first bracket 0, e to the x would be 5/2. To make the second bracket 0, e to the x would have to be -1/2. But of course, as soon as I get that negative value, I go, because what do you know about e to the x? Well, e to the x is always a positive function. Think about what the graph looks like. So this value is of no use to you whatsoever. So the only value we've got which is of any use to us is the e to the x equals 5/2. Now we don't need at this point to think about whether that value or what the value of x is from here, because this next thing we now want to know is the value of tan x. So what do we know about tan x? Well, we were just saying that tan x is equal to sin x over cos x. And once again, we know that sin x is e to the x minus e to the minus x over 2, and cos x is e to the x plus e to the x over 2. So the 2's will cancel and just leave us with e to the x minus e to the minus x over e to the x plus e to the minus x. And the good news is we know all of these values because we've just found out that e to the x is 5/2. E to the minus x, well, remember e to the minus x is just the reciprocal of e to the x. It's 1 over e to the x. So the reciprocal of 5/2 is going to be 2/5. And likewise, on the bottom here, we're going to have 5/2. And then this will become plus 2/5. Well, how are we going to now simplify this? Well, somehow we've got to combine these fractions together. We could, I suppose, resort to a graphical calculator of some description, or we can just multiply. Well, if this is fifths and these are halves, multiply everything by 10, top and bottom. And if I do that, I'm going to get 25 minus 4 over 25 plus 4, which is going to give me an answer of 21 over 29. Okay, well, there's 7 marks for this part of this question. So where are the 7 marks? Well, we've got this original statement, haven't we, that we started with. So multiplying it by e to the x here, that will give you a method mark to start off with there. And then ending up with this quadratic being the correct quadratic, that gives you an accuracy mark as well. Factorising this will give you another mark. or any other suitable method will give you that method mark. Realizing that the e to the x equals -1/2 is not a possible answer gives you a mark, and again an accuracy mark for obtaining the other value. So that's 5 marks, so we've got 2 marks left. So a method mark in here for realizing how you're going to find the value of than x, okay, using shine over cosh, and then obviously working down through to this to get an equivalent fraction for this answer will give you your final and 7th mark. Well, hopefully you found that solution useful. For further support for your revision, please go to the Further Maths Support Programme website.